Okay, so good morning. I've got my new camera here hitched up, so it's going to be a, trying to make this work. Oops, I got the volume on that. Okay, we got audio. That's a good start for me for these type of live streams. So we're going to work some more on Dungeon Fire tiles today. The big focus is going to be, first, I need to do some code cleanup. I've got about like 12, 14 warnings, something like that. They're driving me nuts and probably may cause some bugs. So I want to get that cleaned up. Then we're going to work on getting the negative tiles. So the ones where we start at 0, 0 with our origin tile, but if we try to add one above or to the left, those are in the negative tile space. So we're going to work on those and we're going to get those fixed. Then after that, let's see, what else did I put on my little docket? I'm also going to fix a magic number issue with the room size. So we're going to define that as a constant. Then we're going to build, I've been thinking about this, the combat or the game manager. What I think I'm going to do is I'm going to build a combat manager, and that's going to have smaller components. So we're going to have things like the initiative component. We're going to have a turn tracker component. We're going to have the dice roller component, and all of this. So then I can actually go in later if things change and I want to affect the, change out, say, we got to get rid of the Hero Quest dice pool and we're going to bring in an actual D6 or, D&D style dice or something like that. So then all I have is that one component I can swap out and then just drop in a new one, and we've adapted to the new system. So I'm going to build that just in case, we need those little easements going forward. So, and then after that, we're going to actually build the turn manager, and we're going to work on the linked list implementation. This is totally the wrong angle. I don't know if I can fix that without, no, it's locked in place. Okay. But yeah, we're going to do the linked list thing. What I'm going to do is with the linked list is we're going to build a class that's going to be called the turn node. So that's going to track the initiative. That's going to track, how many actions and stuff like that the character has taken. And then we're going to go through, and when we add that character in via the turn manager, that turn node will get assigned, and then it'll have a ref count and all that stuff so that we can keep track of the unit and how that's all going to work. So I think that's going to cover most of everything today. I'm planning on 2 hours. I might, depending upon, if I get into a really good groove, I may end up doing a bonus stream this afternoon and keep working on this so I can keep my momentum going. And sorry if that just came across really loud as I smacked my mic. But hopefully we can get a good chunk of this done. And then all we're going to have left is going to be the monster spawning. So when we pick those tiles, we have certain ones designated as a monster spawn. So we're going to need to take and make sure that those actually spawn. So hopefully we'll make a lot of good progress on Milestone 2. And maybe we can make up some time. I was getting really worried that we were going to lose a lot of ground on this one because it might overrun. But let's jump over here. Let's take a look at our stuff. And let's see here. We'll transition over. Nope. Helps if I transition to the right scene, so I'm sorry about that. That's the wrong transition. So, okay. Gotta make sure I have the right stuff queued up. So let's go back over there and make sure, when this gets all done, I'm going to transfer to the right thing. There we go. Okay, so we've started work on the movement system and the action turn systems, and we're going to continue working on that today. So I'll just go over some real quick stuff. I do not have my OneNote open. Let's get my OneNote open. Boom. Okay, and so let's take a look here. Our GDD, here it is. So we're going to work on the hero action system. This is going to be incorporated into the turn. So then we're going to track the actions in that turn node. So we're going to work on that. This game manager and turn style. So what I'm hoping basically is to have this stuff in place. We're only going to have the move action implemented at the end of this, but we'll have the framework so then we can build these in as we get to those a little bit later on. So, and then hopefully after that, we'll get the monster spawns, and then we'll get the enemy decision engine. I'm probably going to use the Michael Games stuff that he did in the Metroidvania to try to build like a simple, if this, that, it's just a real simple modular system to try to figure out what the enemy is going to do at any given time. So, okay, so let's get back over here. Let's get into our cleanup. So let's see here. We need to start. Let's just start because we're doing cleanup here. Let's hit start on Dungeon Fire tiles. We're going to work on cleanup right now. Okay. And then just to kind of show you here, I have done 10.8 hours. So we're just shy of 11 hours I estimated yesterday. So that's good. So let's go back here and let's jump into our Godot. Okay. And so let's go here. And so if I run this game right now, you can see here we've got these 13 errors. So I just want to work through these. I want to get these cleaned up just because I don't want these, especially these ones where I'm double using names. I don't want that to happen. So I want to make sure that I get all this stuff cleaned up. So we're going to use all this. We're going to switch this X into a local X. So we're going to use underscore just to say underscore. Okay, so that should fix that 2D array. Okay. Draw terrain, make sure we're not passing anything in here. Y, X. Okay. Oh, I forgot to underscore that X. There we go. Okay. Let's see. Do we have any other references? I don't. Okay, so that's fine. Okay, our rotate array. Let's go ahead and clean this up. New Y underscore X. Okay. We're going to do the same thing here for rotate minus Y. And again, we're just doing this just to make sure that we're referencing local variables and not the global variables, because I do have some global variables up here with X and Y. So I want to make sure that I'm not using the global values. I'm using the ones that are local to these functions. And I don't remember why I did the global ones. I think I did the global ones with the intent of just reusing them in this. I don't believe I'm actually referencing them otherwise. Oh, right here. Here's where I explore from that. This is where I'm using the global X and Y. I'm probably going to come back to this because I think we have a big problem with how we're doing our math when it comes to the negative tiles. So when we get back to that, I think I'm going to have to change out this function quite a bit. Let's see here. We fix that. Okay. Viewport is never used on this. This is the Explorer selection. Yeah. Okay. Well, let's just underscore it then. We are using event. Are we not using the shape? We're not using the shape either. Okay. So let's underscore that as well. Okay. So that clears up that, and delta in the process. Yeah, let's underscore delta because we're not using that. Okay. So let's clear this out. Let's make sure we didn't break anything, because that's always key. And we did. Because now we don't have any tiles. Okay. So we did definitely break something. Okay, so I made way too many changes. This is why you got to be careful when you make massive changes like this, and this is why I wanted to do this separately. So let's just roll back all of our changes here. Stop the game too. Control Z. No, wait. Character. Okay, this is character. Character's fine. It was in game board that we made all these changes. Okay, let's roll back these. Okay, so let's roll back all these. Let's go back and start with just this first function. Let's see here. Here we go. For X, for Y. Okay. Okay, so let's just make sure this didn't break anything. Okay, so we've got our game board. We can move things around. You can hit add tile. Okay. And that's another thing we're gonna work on today is making sure they only move when they need to move. Okay. But see, we can't go to these negative spaces. We can go all the positive stuff, but we can't go to the negative. Okay, so that change worked. Yep, we'll fix that one later today. But now let's go and change this one. Make sure we don't. Oops. Wow. Can't type today. Save my life. There we go. Okay. Underscore, underscore. Okay, so we're getting the train ID and the X and Y. Yep, that's fine. Okay, so let's make sure this works. Okay, so this is the one that breaks it. Oh, because right here, there we go. You see, sometimes you can miss some things. And that's why we should step through it step by step. Okay, so that works. Okay, so now let's go change this rotation array. Okay, so that's the rotate 90. And let's just do the negative 90 at the same time. It'll just make our lives easier. Because I'm pretty confident in these changes. Okay. Okay, so we don't have the warnings. Let's make sure if we add a tile, things are rotating properly. Okay. Who are we up to? This guy? This guy. Okay. Okay, so that looks like it's rotating properly. Of course, this negative, as you can see here, every time we go into this negative space, we're getting errors. So we'll have to fix that. Let's see here. So we got that. Do we have any other warnings? Yeah, right here. Oh, rotate the 180. Yes. Okay, so let's clean this up too. Okay. Morning, Michael. I see that you've jumped in chat. Good to have you here. Okay. Save that. Okay, let's just make sure again. We got no warnings, so that's a good sign. Outer tile. Who are we up to? We're removing this guy. Okay. Move. We're up to that guy. Okay. Okay, so we got that cleaned up. We still got the negative space thing that we have to work on. Let's see here. Okay. So I want to do one other thing. Let's just clear this out and get rid of that. And let's see here. We need... Oh... What is it that I need to do? Let's add in this new... clean up some magic number stuff. I want to get rid of that. So I want to go here and I want to do a constant var. Is it constant var? No, it's just constant, period. And we're going to do room underscore size. Wow, size? It's going to be an int, and it's going to be 4. So when I come down through here, we're going to remove the magic number references in our, what's it called? The previs, show possibilities. There we go. So anything we hear, we got %4. We're going to replace these 4 because that's the room size. And so now when we're going to be debugging this type of stuff, we're going to be able to figure out, hey, this is based, the math is based on the room size versus the this magic number of 4. So we know 4 because there's 4 squares in each thing, but for debugging purposes, it'll just make sense a lot more, because remember, we shrunk our player character from 8x8 down to 4x4 because, you see this 4, does that mean that's the new player character reference, or is that the how many squares are in a room, things like that. So if we replace that magic number with room size, then we know that that is the value that we're doing the calculation based off. I hope that makes sense. So let's see here. So let's go down through here. Let's replace these with room size. I really don't like this. I'm going to probably revisit this here very shortly, because I don't think that this math yeah, because like this should have been 4. This is a magic number here. Yeah, that's a magic number, because here we're +1, -4. And again, this should be a 4. Yeah, we definitely need. I think this is going to be the root of our problem. Oh, actually, no. I think I know what the problem is. Hold Alt and click to. Yeah, you can. I'm drinking coffee at the same time, so I'm not able to use 2 hands at this second. Yeah. So what Michael's saying is, if I want to keep replacing all this stuff, I can just click here. I can click here. I can click here. Divide by 4. And then I can just delete those and put them in, and I can just quickly the iron handler. Yep, one-handed. And just quickly do it that way. That is a very useful trick to have. So let's go ahead and just do that for these last ones here. Okay. And again, just by doing this, let's make sure we didn't break anything. So we can still move all these places here. Let's make sure that we can add a tile. Yep. Okay. Move over here, add tile, boom. Okay, add tile. Yep. Okay, so it doesn't look like we broke anything. All of our errors are still from the negative. Yep, all from the negative tile space. Okay, I believe I saw when I was looking here earlier. Yeah, here we go. Add tile. I think this A star stuff, I think I need to put this in a different function. I think I need this in, let's cut this out of here. I think I need to put that in the draw terrain. I think I need to put it here. Okay. And then what I need to do, so we already used data up here. Let's come in. So let's just make this a local reference then. This is not good practice. I would not suggest doing it this way, but I want to test my theory before I go too far. And if my theory works, we can come back through and we can do a little cleanup here. Cell size, tile size, which valid assignment, cell size and value of vector 2i. Oh, are we just going too fast? Because this is our initial draw. let's, I hate doing this, but let's try it. Git tree, process, yeah, no, let's do physics. Physics frame because it's slower than my other stuff. So let's see if that helps. I hate those solutions. Hate those solutions. Okay, so we got tiles here, we got tiles here. Okay, can we now... Can't go backwards still. We're still getting our errors. Okay, so when we're doing our mouse over, this is where we're generating the errors. Okay, so, whoops. So let's... So then we need to go into the character body. We need to look at the input handler. Input handler. Okay. Oh, you know what? I think I'm doing something that is stupid, and it makes a lot of... It feels like it's going to be backwards. But what we're doing here is we're getting the mouse position, and then we're doing the local map based on the mouse position. So I'm wondering if I'm missing a step here. I think I might be. Let me think about this. Let me think. What can we do for... I feel like I'm missing a conversion here. I feel like there should be 3 steps in this. We get the global position here. Let's do a... Because this is local to map. I feel like I need to convert this to a... Let's try this. Let me try. Let's call local mouse. Let's take our dungeon tile map here. And then we need a... There's got to be like... Oh, 2 local. Here we go. What's this do? 2 local. Transforms will provide a global position into a position in the local coordinate space. Ah, there we go. Will be local relative to the node 2D. It is appropriate for determining positions of child nodes, but it's not appropriate in its own position relative to parent. And how is that different than the local to map? Local to map does... Returns the map coordinates of the cell contain the given local position. So we're not calculating the local position. We're sending the global position into this. So we need this to local before passing it in. Okay. So I missed a key step here. That makes more sense. Okay. So we got 2 local here. Let's take the mouse position. We'll put that here. Somehow I've managed to turn on over... Wait, which insert mode do I have? That's the wrong insert mode. Okay. Okay, somehow I've just managed to like really mess up my stuff. There we go. Okay, so we want to copy this. Part of the problem with having the microphone right here that's between me and the keyboard is sometimes I'm clicking on stuff that I don't intend to. Okay, so then if we take the local mouse and we put it here. Okay, so let's take a look at that. I was thinking that maybe I was drawing the add tile stuff. So let's see if this works. If this works, then I'm going to move that code I just did back from draw a tile from array to the add tile. Okay, so let's try this. Okay, so let's add a tile here. Boom. Nope. Okay, we're still missing something. Why are we still missing? Let's see here. What else are we still missing? So we take our mouse position, we grab it, and it's working in the positive. It's only when we go negative that it's causing problems. We convert. We take the mouse position to local on the map, and we send the local mouse So you get the tile position, and then we get the tile data. Okay. There is no tile data return, but there is tile data. Okay. Is position to cell, get global amount. Does this one have to be local? I don't think so. Let's think about this. Thinking. This is always the fun part. Trying to think through things like this. So we get a target, we do our position to cell, which is, where's our position to cell? There it is. We return, we send in the vector 2i, we take the position, divide by the tile size, and then we'll return that position. Is this going to be wrong because it's... because this isn't the local map? Because again, we're passing in, if I remember right, let's go back down here. Where was the... here it is. The get global mouse position. Oh, you know what? We should probably not be getting the global mouse position twice. We should probably use mouse position here. So then we're not whoops, mouse position, copy. So then we're not double queuing it. But this is the global mouse position. So when we're sending it up here, oh, where was it? Position to cell. Here we go. So we're saying this is global. So I think we need the local again here. Okay, so let's try this. Let's try to take our map to local like we just did. Do we even need this function? That's the next question. I mean, so if we do this, we do to local, and then we pass in the position. Right? No, it's not going to work either, is it? Because that's just going to give us... what's that going to give us? Let's take a look. Let's see what happens. Okay, yeah, that's putting us way over here. We don't want that. Okay. So we got look. Oh, do we need the... what's the other part of the function here? We did that. We did... so we do to local, but then we need the to local map. Let's try this. So let's put that in here, and then we're going to pass in that. So we're going to take... well, if we do this, I mean, we position the cell. I mean, if we keep this as a function, we're already using this prior, so we might be able to reduce our code slightly. Let's see if this works. So let's see what we got here. Okay, so things are in the right spot. Let's add a tile up here. We're still doing the wrong. We still can't go negative. We can go positive. We can't go negative. Okay, so we're still get something wrong here. Let's go back and look at our input. Mouse motion. Okay. So let's think. Let's think through this. We take our global mouse position. We convert it to a local position on the map. And then we... okay, hold on. Make sure we got our methods here. So this takes the global position into a position in local coordinate space. So this will be, where it is on the tile map in terms of the tile map coordinates. This will then take the map coordinates of the cell given the local position. Okay. So this will tell us exactly the X and Y on the tile map. So hence the tile position. Okay. and then we get this. So right now, this is returning the cell. Okay. And we're getting the error. Let's look at our error. Maybe there's a hint here. Can't get ID path. Out of bounds. 3, -1. So that's when we're going up above. So we're trying to get to the tile above. It's saying it doesn't exist. It's out of bounds. Why is it saying it's out of bounds? Let's see what this is. Let's put in a print here just so we can see what the tile position is that we're getting. -1. Okay, so we're getting the right tile position. Okay. But it's only when... Okay. So now here... Yeah, so we're getting the right tile position, but it's saying that there's no ID at that can't get ID path. Saying it's out of bounds. What can we do to try to fix that? So our tile position is right. So this is all calculating properly. If there's not tile data, return. But there is tile data because that's what's generating this. Target is position to cell. Can't get ID path. Line 44. So it's this one right here. Move points, grid, get point path. Okay, so our failure is in the A star grid. So A star is what the problem is. The A star is saying there's no way to get to that target cell. Okay, from our current cell to the target cell. Okay. So why is our A star grid not able to get there? Oh, let me think about this. Global. Why are... Let's, you know what? Let's boot up. Oh, no. I know. Never mind. The idea testing. My solution to not be able to go to negative space was to lock the camera at 0, 0 so you can never go into the negative area. That's not a good solution. A-star grid doesn't support negative coordinates. I know it does. Because I used them in the... what's it called? Terminus Squad. But again, those are... that was an RTS, not a tile base. So it's got to be... I'm missing a convert... Am I not populating the current A-star grid properly? Because does A-star just not see it there? What am I doing? There's got to be something I'm missing. Let's Let's take a look at the game board. Is there something in the game board I'm missing? Where are we? Maybe we should take this code that we had. Let's move this back to, cut this out of here. Let's put that back into our add tile array. We didn't need this. And then we could do, that should be fine. Let's just see if this makes any difference here. Nope. Okay. Okay, so that didn't make any difference. Oh, you know what? I think, actually, Michael, I think you might be in the right ballpark. Because if I remember correctly, A-Star Grid still has a region. Even if it's not like all the tiles, it's still set up as a region box. So I think I'm missing where we have to expand the region into the negative space. I think that might be where I'm missing. Let me think. How are we going to do that? We wouldn't need to do it in right here in this stuff, because see here we have, this is the region. We have the rectangle and vector, rector. Yeah. Anyway, and we're setting it at 0, 0, and then we're basing it on the viewport rectangle. Okay. So I think this I think is where my problem is. Let me think through how we can do this here. We can do, how do we want to redefine the region? You know what? Why don't we just do, let's do this. Let's do A star grid.region, and then we can just reference the how are we referencing this right now? Do I actually have a export for the dungeon tile map? Yes, I do. Why don't we just set the region equal to the dungeon tile map, and we'll just get its rectangle. Get used rect. Let's try that. Let's see what happens here. So let's add a tile. Boom. Oh! Such a stupid answer, but it works. Oh, God. Okay. Who am I up to? There we go. Why am I no longer able to add tiles? Okay. Well, that's... okay. So who am I up to? Who am I up to right here? Okay, let's go here. Let's make sure we can get the... we'll move you over there. Yeah, sure. You can move there. You can move there. Okay, now let's see if I can add a tile. Okay, well, apparently I can't add negative tiles. I can add positive tiles. Okay, well, we're making progress. So that's the good sign, at least. We're making progress. Okay. And this is probably back to my this function is just so bad. I even said it was bad when I wrote it. Okay, so let's see. We can now move into the negative space once the tile is successfully added. Okay, let's see. Let's rethink this, because I really don't like... I don't like the way that this is working, because it's just so... If this super long formula, and I don't know if I don't think it works in negative space. -3 plus 1 is 2. Or no, -2. Yeah, so I don't, this is not gonna work for negative space. Okay. Let's think about this here. Let's do, how we want to do this. Let's take a look at how we can change this. So we're checking the square that we're exploring from. We're dividing it by 8 because this is the tile size. So that's tile size. Well, let's use what we just did with, I'm going to just comment all this out for right now. Let's use what we just did for the mouse. So let's do a var, let's do a local position, and then let's use our dungeon tile map stuff for it. So let's do, like, say, dungeon tile map, and then let's do map to local. And then we're going to send in the characters global position. Wait, do we want to do map to local or local? We might have to do the local. No, we want to local here, not map to local. To local, because we're sending in the global position. And so we're going to pass in the character. What do we call this again? We call this turn order right now. Turn order current actor index dot global position. Okay. So then we'll get where the character is on the tile map in local reference. Okay. And then if we want to find its position, like what cell it is, we can do, we have this function, this position to let's use our thing. Let's just do cell, and let's do the pause. What do we call it again? Pause to. Oh, right. That we did that local with the. Never mind. That was in the position. The game board was in the character body. Oh, can we call it on the character? If we just do cell here, and then we call it on the character. So if we take this right here, current turn order, take the turn order, that, and then we get the pause to cell, right? Oops, underscore. Let's double check the character reference here. Pause to cell, we passing a position. Okay. So if we're going to pass in a position, you know what? Let's just do this. Let's just take this function. We're going to also copy it over here. Let's just save ourselves a little bit of a headache. Let's just put this here, and then we can just call in the pause to cell, position to cell. Okay, and then we'll pass in the current character global position like that. Okay. Oops, cell, not call, cell. Okay, so now we'll know where they are on the tile map. This will give us an actual X and Y coordinate. Okay, and then what we need to do, so that gives us their actual position. So that becomes our explore from. Okay, so that replace all that to replace this line. And we need to figure out where the room's origin's going to be, I think. So if we figure out where the room origin is, and again, we're using top left coordinates, or we're going to use the middle. What are we doing down here? We're doing rooms. We get cell tile data explorer from when we divide by the room size, then we times it by the room size. Okay, so we are just getting that reference. Yeah, I hated this function when I wrote it, and I think rewriting it is probably gonna be the best. So let's figure out where. We need a room origin. Okay. And then let's do a do we want to call it like a snap? What do we want to call it? Snap the room? We'll just call it snap room. Snap room. Because then what we can do is we can just kind of figure out what room it's in. We'll get back its coordinates here. So let's go ahead and do that. Create this new function called snap. Whoops, snap room. We're going to take in. It's going to be the cell of where it is, and that's going to be a vector 2i. Okay, and then we need to pass back also a vector 2i. Okay, and then what we want to return is, and let's do a vector. Let's make sure we'll return the right value here, and then let's do a. Let's take the. So we want the lowest because we're going for the top left. So do we want the lowest? Because remember, we're trying to deal with negative rooms. So if we take the current character position, like his X position, we divide it by the room size, and then times it by the room size, like we're doing down here. And then we can take... Well, if we use like a floor command, that's going to give us the lowest. So that will be, that should account for negatives, I believe. So if we do that, if we do floor and we want to use a integer, we're going to do cell.x, and then we're going to divide that by, we want to divide it by room size. Okay. And then we want to times this by the room size. Is that going to be right? Am I doing this? Am I... So we get the lowest value. We want to, yeah, let's try that. Let's make sure this works right. Let me see here. So it'll round whatever value is in the parentheses down towards negative infinity. Return the largest whole number that is not more than x. Okay. The largest whole number that is not more than x. Okay. So that should work for negative, because then it will take whatever's, if we're at -3, it should return -4, because -4 is not going to be larger than x. And if we're in space 1, it's going to return 0, because 0 is going to be the next number lower. Okay, so that should always put it in the right spot. Okay, so I think that's what we want to do. Okay, so let's go back here. Okay, and then we need to do the same thing, but we need to do this for y, right? And that should get us our room origin. So let's just do a print room origin. Let's make sure that this works. If I'm thinking right. I'm trying to think. Do I need to do another... Yeah, let's just do this right now. Let's test this. Okay, let's see here. So we got here. You know what? Let's go back to our character. Where's our character? Character body. Let's get rid of that print. Where did I put that print? Input, print tile position. Yeah, there we go. We don't need the flood that stuff. Okay. So if we need to do here, we're in this guy right here. Let's add a tile. Error, too local. It says dungeon tile map does not exist. Oh, because I copied that out of the character body, not out of this. So this needs to be dungeon tile map. Okay, let's try that again. Add a tile. Okay, so this says the tile is in 0, 0. Okay. Well, now I can't add a tile, so I can never test it. But so if we come down here, just move everybody down here because all these should report 0, 0. Yep, still 0, 0, even though we're in 3, 3. Okay. Okay, so that's working. Okay. So now we need our logic here to reevaluate this. So let's see here. So then we need to figure out where we are in relation to the room. So let's take so then we can determine which side we're on. So let's do var local x, and then we're going to say that's going to be cell.x minus the room origin.x. Okay, we're going to do the same thing here for y. Local y minus y. Okay, so that'll give us our x and y's within the room. Okay, so then if we want to do, like, say, up, we want to see if we can explore up, right? Then what we need to do is we have to say if local y is 0, so if we're in the first row, then we can say our target. So right here, y is 0. We can use the target is going to equal the room origin plus vector 2i, because when we're working integers. And then we want to do 0 and room size. Right, yeah, 0 room size. Wow. Room size. There we go. Okay. So our target is now 0, 4. Right? I get myself all confused. I'm trying to rework this. And now I'm getting myself all discombobulated, right? So we get our target, and then we need to see if that target actually exists. So let's take a look and see if our dungeon tile map, and let's get a get cell cell tile data, and we want to see if that target has anything. So if it equals null, like we did down here, so basically we're just changing this, and then if it's null, then we do want to use basically want to call this function here. So we want vertical explore, and we're not using explore from anymore because we're already calculated this. Explore from x, room size. So this becomes target x and target y, right? Yeah. Target.x, comma, target.y. And then we pass it the vector 2 down because that's the orientation the tile needs to have. Okay, so if this is working, we should be able to explore above us. Okay, add a tile. What did I do wrong here? So I'll just line up down here. Okay, what did I do? I did something really stupid. Let's think through my logic here. What did I do? Did I set the target wrong? Target equals our room origin, so in this case 0, 0, plus vector. Oh, if it's up, we want to go negative room size. Right? I want to go negative room size. Yeah, that's what I did. Not 0, 4. 0, negative 4. Okay. And then we want to do it down. Okay. Okay, so let's, again, try this. Make sure that our little dude's not... Okay, apparently his turn's over. His turn's over. Okay, there we go. Okay, but now I can't because that tile is not... Let's just see if we can get one more tile here that's... Nope. See if we can get a tile that goes... There we go. Okay. Yay. Okay. So now we just basically need to pivot this to the other directions. Wow. Okay. This was a a long ways around, but you know what? It got us there. So let's take this. Okay, let's copy this. Let's do down next, because that'll be easiest here. So if local y is going to equal 3 to go down, right? Do we want to do down, or do we want to do... You know what we should do? Let's make it modular. In case, like... Because right now, the 4x4, I feel like it works for the tile set I have, and it works based on the Dungeon Dragon stuff. But maybe if I want to do rooms that are a little bit more interesting, maybe eventually I want to spin this to, like, an 8x8. So let's set it to room size -1. Okay, so then it'll just be whatever the maximum room size is, -1. Okay, so that will give us 3 in this case. And then here, we want to go positive room size. And then we want to pass it the vector 2 up. Okay. Right? So let me think here. So we're targeting here. We're targeting down, see if it's there. And then we should populate. Okay, so let's try this. Let's make sure my logic is proper. Hey, there we go. Perfect. Okay, excellent. Okay, 2 more directions, left and right. Left and right. So let's start this. This will be, if we're doing 0, this would probably be left. So let's put this in here. Let's do left. Okay, and we're going to do local x equals 0. Target room. Okay, so here we're going to do negative room size here and 0 here. Okay, this logic stays the same. We've got the target x there, so this would be down. So we're trying to go left here, right? Right, negative room size. Yeah, we're trying to go left. Okay, and then you know what? Because it's pretty simple and straightforward. We're going to do here, we're going to do room size -1. We're going to change this to room size and then change this to right. Okay. Oh, cross our fingers. Let's see if this works. And then we kind of rehashed milestone 1. But let's see here. Let's get rid of that. Okay, so that oriented it improperly. Okay, so left, so this should be right, because down, yeah, it should be opposite. Okay, so this should be right, this should be left. Okay, because this is saying when we're putting it to the right. Okay, so this is saying when we're exploring to the right, we need to face the opening to the left. Okay. Okay, there we go. We'll go over here. Okay, there's the opening. Up. Okay. Yay! Okay. So I think we fixed our tiles. Let's get rid of all that old code. I think this is going to work much better. Okay. Wow. Okay, so we got that. We've got the tiles. We've got the negative space working. So that's good. What else did I have on my docket today? I had fix negative tiles, do clean up the code, which we did. We got a couple more. Let's just make sure we clean up our code here. Integer division. Well, we're saying it's there. What if I put this into a float? Is this gonna... Will that clear up that error? It does. Okay. So as long as I force this to say it's going to be a float result, so I'm typecasting it right off, that clears up that error, right? Yes. Okay. Perfect. Okay. Okay. So we got that. We're clear and free of all of our warnings. So that's good. So let's move on to our actual turn manager. And I've done some thinking on how I want to kind of do all this stuff. I think what I want to do is I want to have a like an actual combat manager, which I kind of mentioned in the intro. So I want to be able to make it so I can break out all the different parts, the initiative, the what do I call it? The turn manager have its own component. The initiative system have its own. The dice resolver, probably the enemy controller. Think of oh god, what was his name now? Zardon or whatever in Hero Quest when you play the evil wizard guy that controls all the monsters. I feel like it was Zardon, but that may be wrong. And then a reward system. So when you defeat the monsters, do you get treasure? Do you get something like that? So we can have all those as separate systems under a combat node. So let's build that out. Let's see, where are we? We're at 11, so it took us an hour to do that. Let's see here. So let's add in a new node. And this is going to be our combat tracker. Yeah, combat tracker. Okay, and then underneath that, let's add in our turn manager. Oh, that's just a node. Turn manager. Okay. What were the other ones I wanted to add in? I want to add in the initiative system. Another node. So initiative system, a dice roller, enemy controller, reward system. Okay, so let's call this INITAT. Initiative system. This will be our dice. Instead of roller, let's call it dice resolver, so that we can do multiple things here. Let's do our enemy controller, and then let's do our reward. Let's call it reward system. Okay. Okay, so what we need to do is let's get into our turn manager. So we need to track all of our turns. So the first thing I want to do, because we're going to be doing linked list, we need to have a node on each character, on each monster, that's going to track all the information related to their turn. So let's create a new core component. Let's create a new folder, call it combat tracker. Okay. And let's create a new script in here. And we're actually going to do, let's not do a node. Let's do a, what is that thing called? Is it just like a ref count? Something like that. empty. Yeah, we'll just do an empty inherits ref counted. There we go. Yeah. So this is just, it's something I've seen a couple of videos and I wanted to use it. It's a way to have like a bare bones script. So it has no node properties. It has nothing else. It's just going to contain actual code. So let's do this. And then let's call this our turn node. Turn node underscore turn node. Okay. Class name turn node. Okay. Because we're going to be definitely using this for a lot of stuff in this game. So we're going to have our monsters are going to have it. Our players are going to have it. Anything else, maybe if we have environmental conditions like a spell creates an ice storm or sets something on fire, it's going to have a turn because that's going to need, time to act. So we're going to need to make sure that we put something on there so that it can be referenced in the turn system. So let's give it a var and let's go. Speaking of that, I was going to call it character, but let's see. What do we do? Turns. We take turns. We turn character. No. Let's just call it an actor. Yeah, actor. That sounds good. Actor, and it'll be of some type node. We need to have, because I said we're going to pass everything via initiative. INIT. How do I spell initiative again? ATIVE. Why does that look wrong? INIT. Googles, come to my rescue. I think I'm spelling initiative incorrectly. I am. I'm missing an I. Okay, that's why it looked wrong. Okay. Initiative, and that's going to be an integer. Yeah. What else do we need to know about the turn? We're going to probably need to know. We need to know their actions. Actions. I don't like calling it action. Actions. Action is just such a broad term, so I don't want to use actions. I want to do action. Some way to track the number of actions. Action number. Action. Possible actions. No. Sure. Action points. Sure. Let's use that. Action points. Wow. I've programmed in so many different languages over the years that my cases for my variables are all over the place. Okay. So let's see here. We've got action points. Do we need anything else? Do we need a... Do we need to say they have completed their turn? I don't know if we need to track that or not. Yeah. I think that's good enough for right now. Here's the key part. This is what we need. This is our linked list. So what we need to know is the next actor. Right? Next actor. And that's going to be a turn node. Okay? And then we also want a double linked list so then we can go forward and backwards if need be. So we need to know the previous actor as well. Okay. So we got all that. Now we just need a function. We need to initialize this. And we need to pass in, our actor. Probably don't want to use actor. We'll just call it, we'll lowercase it, actor. There we go. And that's going to be a node. Okay. And then we need to also, when we call our initiative system, we need to pass in the initiative. So INI underscore INIT IATIV. Still looks wrong to me for some reason. Okay. So then in here, we need to then assign the actor to equal the actor. Okay, and then we need the initiative to equal the initiative. Oops, underscore initiative. Okay. What did we do wrong here? Could not find type node. Oh, node. There we go. Okay. So then when we initialize the turn node, we're going to assign the actor and the initiative. Okay. That's good there. So here's our turn node class that all of our characters, all of our monsters are going to get. Okay. So let's go into the turn manager. Let's create a script for this. Wow, attach script. There we go. This one will be a node because we're going to have it in the tree. We'll just leave it empty for right now. Okay, let's create this. This is going to be a class name underscore name turn. What were we call it? Turn manager. Okay, turn manager. Perfect. Okay, so what do we need in the turn manager? We need some signals. We need to know what the current node is. So let's start with the signals. Signals. We need to know that the turn started. This stuff is going to be very useful later on, especially when we get into the. Actually, should this be a node? Whoops, no. Yeah. This will be useful later on, like when we have an initiative bar, so we can see like who goes when and when the enemy slots in, so we can transition the UI as needed when the turns start and turns end. So let's see, what else do we need? We need a turn end, of course. Turn, oops, lowercase, turn ended. I don't have my space in there. There we go. Okay. We also want we want to know when an actor gets added, because we need to update that bar again. Okay, and then we also need one for an actor, ACTOR, removed. Okay. Okay, so then when the goblin dies, or orc we're using, when they die, they get removed from the thing. We need a variable for who our current, and what the current node is. Let's call it current turn node. Yeah, current turn node. Okay, and then that's going to be of type turn node. Let's set that one to null to start with. What else do we need? We need a way to keep track of all the possible actors. How do we want to do that? Could just use. I mean, the point of using this is to avoid the array, but we still need a listing. Let's just use. I guess a dictionary just probably makes the most sense. So let's just use a dictionary. An actor listing. Yeah, that works. Actor listing. And let's make that the dictionary. And then we'll just, by default, whoops, dictionaries use those things. There we go. Curly brackets. Okay. So then we've got that. Now we need a way to add in an actor into the turn manager. So what we need to do here is, let's do a function. Let's do insert add. No, let's do add by. Everything's going to have initiative. So let's just do add actor. I was thinking, is there going to be a time where we don't add the initiative? Like maybe at the beginning of the game where we just set everybody up. Let's just use add actor. I think that's going to be probably just the easiest right now. But we need an actor. So that's a node. And then we also need the initiative. That's an int. Okay. And then that's going to... do we need a success? Do we need to pass back, yes, this succeeded? Or do we just make this a void? How safe do we want to be with our code? Let's make it a safety. We could say yes, this succeeded, or no, it failed. I don't think there's going to be a case of where it's going to fail, but you never know, because that might be something that comes up later. Yeah. So what we need to do now is we need to take the actor itself, and we need to add set its initiative. INIT. No, we need to add the actor's turn node. Hold on. Let me rethink about this. So we've got all this. We need to take the actor in, which the actor is right now just a character body. Does not have a turn node. We need to take its initiative and add it to the thing. So let's take... So let's do a var. We'll do a new node. This is going to be our new turn node. There we go. New turn node. And that's going to be a turn node dot new. Okay, so we're going to attach this to the actor. We need to pass in the actor itself, and we need to pass in the initiative. Oops. Helps if I spell it right. Initiative. Okay. Yep. Okay. So we pass in, we'll establish in the turn node the actor and the initiative, because in turn node we bound those together. Okay. Okay. So now we've that. Now we need to attach. Do we need to attach it? I don't think we do. I'm trying to remember now. This is the problem of doing linked list only like once before. So I'm just trying to think about how to keep track and attach everything. So let's take our actor listing, because we need to add it to that actor listing. And then what we need to do is we need to add that in. So actor listing in the actor reference, and then we're going to add in this new turn node. Okay. So now the turn node is in our dictionary. Think about this for 1 second here, because what we're doing right now with this is we're not actually attaching the turn node to the character. We're associating the turn node with the character in this dictionary. Is that how we want to do this? Let's keep moving forward. We'll come back and ponder on that point later if need be. Okay, let's see what we want to do. Let's find out if it's the first node or not. So let's say if the current turn node equals null, then we're going to assume that this is the first character. So we're going to do the new turn node dot next. Next actor is going to equal itself, right? Because we need something in there, right? Turn node. Okay. All right. And then we're going to do the same exact thing for the previous. Yep. Is it previous turn node? Oh, no, this is new turn. Whoops. New turn node, previous actor. There we go. Wow. Brain, coffee, need to consume more. Okay. So we got that new turn node there. We need to. So basically, it's a self-reference and linked list right now. It says the next person is me, the previous person's me. So that's only going to happen if it's the very first item added to our linked list. So then, if it's not the first, we should probably just, and then we also want to set the current turn node equal to this new turn node. Okay. So we also say that this is the current person who's up. Okay, and then what we want to do is we want to jump out. This is something I've been trying to do a lot more of going forward, is instead of doing like if else, go through the thing. If it hits this condition and that's all it needs, kick it out of the function. Don't even bother processing the rest of the function. So I've been trying to get a lot better about doing that. And then down here, we're just going to, if all else fails, we'll just return false. This will clear that issue up there. So if it's not null, the current turn node, we're going to need to loop through everything. So we need to go through and try to figure out where things need to exist. How are we going to do this? Let's see here. So let's write the logic first. How are we going to check? So we're going to say if my initiative, okay, is greater than the we need to establish a check node. Okay, so let's do a check turn node. Okay, equals current turn node. Okay, so we're always going to start with whichever one's current, because right here, if current node is null, then we're just going to set it. So after that, there's always going to be a current turn node, so we can check the check node. So if our current initiative is going to be greater than the check node dot initiative, okay, and then what we need to do is we need to then assign the previous node var, not var, var. We need to take the, let's do a var previous node underscore node. Okay. We're going to say that equals our new node, our new turn node. Okay. No, that's not right. We need the check turn node dot previous actor. Okay. Check turn node. All right. Identifier check turn node not declared. Oh, because I didn't put a var in front of it. Wow. Coffee, not potent enough this morning. Okay. Let's see here. Previous node, check node, previous actor. Okay. So then where are we again? If our initiative is greater than the current turn initiative, then we need to take the previous node and we're going to set the previous node equal to the previous actor. Okay. And then what we need to do is we're going to set the previous node dot next to the new turn node. So what we're going to do here is we're going to say the next thing in the list is going to be this node. Okay. Or the previous node. So because what we're saying is, say our initial one has a 10 initiative. Okay. So we set it up here. The current turn is player one with a 10 initiative. So we come in here. Our turn node is player one. We're player two, and let's say we have a 15 initiative. Okay. So we come in here. We say player one is currently active. Our initiative is 15, which is higher than player one's, which is 10. So we're going to take this previous node, the new variable that we're setting, and we're going to take player one's previous actor. And then because we're higher in the initiative, we're going to take their previous actor and assign it as our next one, or assign us as the previous. So we're saying we're cutting in line in front of you, player one. Player two now is going to be your previous actor. Okay. Okay, so if we do that, or the previous actor, so then we need to do now we need to adjust the previous node equals the new node. So the new node, the new turn node dot previous actor is going to equal what the previous node. So in that case, it's going to be prev node. Okay. So then making sure we got our logic here. So our previous node, so our new turn node, this is going to be the turn node for player two. Player two's previous node then becomes player one because we have a higher initiative. Is that what I just did there? Did I just do that backwards? Because it should be the next node. New turn node, previous actor. Oh, we're taking the previous node from, so whoever was in front of player one, we're now taking that. So it could be three people. It could be player three was in front of it. Now we're taking ownership of player three. Okay. I was like, wow, my brain broke. Okay. So we got a new turn node, and then we need to set up the next. So we're basically going to be doing the same thing. So we need to set up the next node. So let's do a so new node, our new turn node dot next actor is going to equal the current check node. Okay. So then the next actor, because now I'm going on 15, player one's on 10, player one will be next. Okay. So that's that. And then on the check turn node, we need to set up their previous actor is now going to be us. So that'll be the new turn node. Okay. So now we're telling player one, we're going before you. We're setting ours to be player one. We're also stealing whoever player one's was prior to that. Okay. And then we can return out from there. Return true, right? Okay. And then if that's not true, what we need to then do is just tack on the end. So then we'll just do our check turn node equals check node check turn node dot next. All right, does that make sense? Because if we take our check turn node, this is player one. Player one equals player one dot next actor. Oh, because now we're starting to walk down the list. Yeah. And now we got to put it into the loop. Right. That's what I was thinking. next turn. Okay, so we need to walk down the linked list. We need to keep going, progressing forward. Okay, and then we need to see if the loop's done. So we can say if the check node equals the current turn node, right? And then here we can break out of the loop. Okay, so what we can do is that up here, we need to, I hate doing this, but it seems to be the most useful version. We'll just do a while true. We put that all in here, and then break out of that. What did I do here? Assignment is not allowed inside of an expression. Oh, equal, equal. Yep, there we go. Equal, equal. Okay, we break out of that loop, and then we also need to do, if we need to add them to the end. So let's call tail. Yeah, tail's probably a good. Equals current turn node dot previous actor. Okay. Okay, and then we can just do tail dot next actor. Oops. Next. Wow. Tail dot next actor. Okay. So what we would need to do then is the next actor is going to be our new turn node. New turn node. Okay. And then we need to also do new turn node dot previous equals whatever the end, the tail is of the current chain. So let me think about this. We got this right? Boy, this is very, very confusing. So we've broken out because we've gone through the entire thing. We've gone through the entire list. Tail. So if we set the last one, whoever the previous actor is, the next actor is the new turn node, previous actor, set to the tail. Okay, that makes sense. Okay. Yeah. Okay. So if we do all of that, that should be all we need to do to add everybody into this turn order. Okay. So let's see, what can we do to track this? So let's go into our game board here. Let's draw in a reference. Combat tracker. Not combat tracker. Turn manager. Copy here. Okay, so we set up our turn order. Okay, so let's do turn manager dot add. What do we call it again? Add actor. Add actor. Here we go. Copy. Okay. Add actor. Okay, and then we're gonna add it. Oh, you know what? We're gonna have to loop through. So let's loop through for actor in turn order. Add actor, and then we need to do an initiative. So let's do a descending order. So let's do I equals 25. Okay. Add actor I, and then do I minus equals 5. Okay. Oops. Var. There we go. And then what we need to do is we need to have a way to look at our so that will add them into our turn manager. We need a way here to take a look and walk the array. What can we do to walk it? Let's do do we just go through the dictionary? We have a dictionary. Let's just print out the dictionary. Let's just do that for now. Okay, so let's go back over here. Let's, where am I? Right here. Boom, boom, boom. When this is done, do a print, turn manager dot dictionary. Okay. So let's just run this. Next actor value. Did I not do? Next actor, turn node. Okay, so we're calling the add actor. We're in here, our new turn node, actor and initiative. Valid assignment primary key next actor with the value of type GD script. What did I do wrong here? It's not liking the value. What did I put in turn node? Turn node is next actor is of type turn node. Oh, because here I put these should be turn nodes. Those shouldn't be ints. Those should be turn nodes. Nope, those should be node int. Yeah, because we want to pass the actor. Okay. So let's see here. New oh. Wow. This is what I get for naming my stuff the way I did. Okay. Nope. Nope. We got ourselves into an infinite loop. This is why I didn't want to use that while. And we may have crashed Godot. Yep. Looks like we did. Hey. Come on, finish crashing. Okay, finish crashing. Let's see. Okay, so this is why I didn't really want to use this while loop. Check turn node equals check turn node dot new actor. Okay, well, for how about if we do this? Let's cut this. If we take this out and instead of while true, while check turn node does not equal current turn node. Now that's not going to work because we assigned the current turn node down there. Let's see here. Well, let's see. For testing purposes, let's just remove the while loop. Actually, you know what? Let's just do var checking pool equals true. So while checking, and then down here, just to make sure we kick out of this, we can do checking equals false. Okay, so this will only ever run through once. Okay, so let's try to run this here. Okay, so then let's see, we added in character body, we added in player 2, we added in player 3, we added in player 4. Okay, so we did that. Let's do game board. It's almost lunchtime. Let's see here. Game board, print, actor listing. I don't think I can do this. I don't think I can do initiative. I don't think that works. Let's just check. Yeah, I didn't think so. Okay, so we're going to print that out. That's going to give us our ref counts. Oh, you know what we can do? We can do for actor in. And then we can print actor. Actor.actor. And then we can print actor.initiative. Oh, right, because it's... Fine, we'll just print the actor then. Boom. Okay, so that makes it a little bit better. Okay, so then we can see the order here. Okay. Okay, so we got that. What else do we need? We need a way. Need a way to see the order. Because right now, this is just the order that they're loaded into the dictionary, which is the order they're added into the turn manager. Okay. Let me think about this one. Okay. I'm going to step away for just a moment and use the restroom, and I'll be right back. Okay, back. Sorry about that. Okay, so let's see. Where were we? We are trying to figure out how to get our... we want to try to look at our initiative order. So we want to try to get that to print out. So let's take a look here. So we probably need a function in here to, show turn order. Let's make it output an array. That'll be easiest to do that. Okay, so what we need to do... Oh, no, I was trying to fix this while checking thing. I'm just curious if I do this. Oh, no. Return. Why is that not... Well, let's just take that out for right now. Okay, let's see if this checking actually works. Save everything, because this very well may crash again. And it did. Okay. Okay, what am I doing wrong in my logic? I probably have an infinite recursion. Well, I mean, I do have an infinite recursion loop. Let's put some output in there so then we can figure out what's going on. Okay. Crash, come on. Crash, crash, crash. Close. Bring it back up. What's this? This is... How many times did we crash the program? Okay, there we go. Okay, so let's see here. Let's do... let's go back through here and let's look at our logic. So if our current turn node is null, assign it to be the first one. Okay. Return true. Right? Because we assigned it. Should we also put checking equals false right here? That should break out of the loop for the first one. Let's add in a... Let's figure out where it breaks. So let's add in an output here so we can see. We can do print actor. Oops. Print actor. Okay. So let's take a look and see where... So we should be able to add the first one. It's probably when we add the second one that it's going to break. Because we're passing... Oh, you know what? We should pass it in. Because we have if initiative is greater. Which it's not. So let's go back into our game board here. Let's do this the opposite way. Let's start at 5. And then we'll do plus equals 5. Okay. So now what we're doing is we're actually going to add in... This should just add them onto the tail. So this shouldn't crash, I don't think. Because we're going to pass this, we're going to return true, so we should never hit any of this stuff to make the while loop continue on. Let's see. Okay, so it doesn't like... Oh, because I did next instead of next actor. Okay. Okay. So we went through here. Yep, we went through each one. We added it. Okay. Okay. So what we have. So we don't need, yeah. Checking equals false. Okay. Okay. So we got that. So it's only if this doesn't work. So if we have less than or equal to, which would be this part. So how do we advance to the next element in the linked list? Okay. So we've got this part is working, should be working fine. Oh, you know what? Let's do our printout. We want to see our actual initiative stuff. So let's do a function, build, what's it called? Show turn order. Show turn order. And then we want to do it. We want to do an array. Okay, and then var results right now equals this. We can return, return results. Okay. Okay, so then what we need to do is we need to loop through. Oops, you just do that right there. We need to loop through all of our node. Because we have a double linked list, we don't have a head node because everything's going to be going in a circular order. So let's try. We have current turn node. So let's start with the current turn node. Let's call it a var. We'll call it a start node, start turn node. Okay, start turn node. And then that's going to equal our current turn node. Oops. Okay, and then so what we need to do is we need to keep iterating through and then coming back, and once we hit our start turn node, then we can say our array is done. Okay, so let's do this. Let's do. Okay, so we're going to take our current turn node. We're going to do results dot add append. We need to append an array. Or do we want to just append? Yeah, we can just do this. We can just do results append current turn node. So then we put that in. So we're going to say this is whose turn it is. And then what we want to do is we want to do current turn node equals current turn node, not next actor. Okay. And then we're going to just call this again. And then we're going to say here if current turn node equals start turn node. You think this is again a while loop, and I don't really like doing the while loops, but if the current turn node does not equal this, then what we need to do is we need to run through these two things again. Okay, so then here, let's change this to while the current turn node does not equal that. Then we can run, we do these like this, like that. Okay. and then we can just return the results. Okay. So that should work, because what we're going to do, we're going to come in here. Our results array is going to be empty. We have our start turn node is equal to our current turn node. So we're going to append the current turn node in. The current turn node is then going to be set to wherever the next actor is. And if the current turn node does not equal the start turn node, we're going to append it and then advance it. Append it and advance it. Append it and advance it. If there's only one node, then it's going to come back and just say, boom, that's it. It's not even going to execute this while loop. Okay, so that should return the results array. So if we do this, we come back to our game board. There we go. And we do print. Forget that. We're going to just do print turn manager dot show turn order. There we go. Okay. And then it comes in and it says, here's our ref counts. So first one is 967, 689, 672. Oh, because we don't have the ref counts here. Because this is the character ID. This is the ref count. Okay. Okay, so now we need to find a way. Let's go back into our print. Where is it here? Print manager. We want this is returning the current turn node dot actor. Oh, how about initiative? There we go. So then we're going to add the initiative like that. So now we should just get a result of the initiatives. 5, 10, 15, 20. Okay. So that's the order it's going in. Because that's the order we've added them into the dictionary. So let's take a look here. So did we do this one backwards? So if the initiative because our current turn node, we're not advancing. We're setting the first one we pass it, which is going to be 5. We're going to pass in 5. We're going to set that person as the current turn node. Right? Current turn node. Okay. And so it's going to start 5. So what we should be seeing is 20, 15, 10. So it should be 5, 20, 15, 10. That's what we should be seeing. We're not seeing that. So we're not adding them in the linked list in the proper order. But it's showing in the order in which we add them into the dictionary. Okay, so we're coming in here, adding the actor, adding the initiative. Okay, so let's work through this, and then my wife's bringing home Jersey Mike's, so I'm gonna have a good lunch. Print actor. You know what we should do? We should just do print initiative here too, just so we have some nice output that we can look at. You know what? Let's not do it that way. Let's do it. There. That should give us the initiative. Yeah, 5, 10, 15, 20. Okay. Okay, so we come in. We have our new turn node. And that's going to be, we're going to take the turn node class. We're going to build a new node for a new ref count. And then that's going to be the actor and initiative. So we're going to bind those in. So, and then we're going to add the actor listing. Do I need this part, the actor listing? Do I really need the dictionary? I think we're going to need the dictionary later, but anyway, we're just adding it right now into the dictionary. Okay. So let's take a look here. We're checking, so let's go through. If the current turn node is set to null, which by default it is. We're going to take the very first entry we add in here. It's going to say the next actor is going to be this. Okay. So we're setting it self-referential. We're also going to set our current turn node to the new one. Check-in equals false. Okay. If this is not the case, we're going to come in here. We're going to set the turn node to whatever the current turn node is. So we're, in this case, think of it, we're comparing everything against this right here. So check turn node is going to equal player 1. If player 1's initiative, which in this case is 5, mine is 10, so mine's greater, I'm going to set up a temporary previous node, and I'm going to set that equal to player 1's previous actor, which in this case is null. So this, or not null, itself. So it's going to set player 1 as the previous actor. Okay. So then player 1's next actor will be set up for me, because I'll be, player 2 will be 10. So this will be player 2. Player 2's previous actor is going to equal player 1. Okay, so that works. We have 2 of us. The next turn node dot next actor is going to be player 1. Player 1's previous actor is going to be player 2. Okay, so that makes sense. That works fine. Because we're greater, so we belong to the left side. If we are not greater, so say player 2, or player... what are we thinking right here? So player 3 comes in. Player 3 has an initiative of 15. Okay, so we're going to start off with... Oh, I see why it's happening. Okay. We're not looping through because 15 is going to be greater than the current turn node. So it's going to go on the left of the current turn. We're not validating that it belongs to the left of the current node, because it might belong 2 spaces to the left of the current node. Okay. So what we need to do is then we need to check. I don't think we need the return here. I think this is a problem right here, because I think we're quitting out before we check the other linked list items. So I don't think we're supposed to return here. I think this is our problem right there. This should fix our array issue. Oops. That was not Control S. Let's try that again. Okay, let's try this. Let's see if we crash. We crashed, but at least we have information. So we got 5, we got 10. When we added in player 3 is where we crashed. Okay. So it's while we were doing the looping. So we're learning data. We're moving forward. Come on. Don't you want to close? There it goes. This is why I hate while loops. There's probably a better way to do it. Like, instead of while checking, we can just do like maybe, oh, you know what we could do? We could probably just do, there's got to be a way to do it like a size. and we can just keep looping through. But we don't want to do that because if we're shifting things, we need to keep checking. Anyway, we know where it breaks anyways now, because when we pass in, we already have 5 and 10 into our output. It's when we're trying to put it to the left. So this all works. It's when we get to here, things start to break. So our check turn node. So right now it's player 1. Here we're going to assign check turn node equals player 1's next actor, which in this case would be player 2. So player 2 does not equal the current turn node. So then we do this loop again. So check turn node now is player 2. Okay. So current turn node, we can skip over that. And this is where it is. Because here we're changing check turn node. Here we're redefining it. We're setting it back to 1. Okay. So this is where we're messing ourselves up. Because when we loop it around, here we've changed it to the next thing. But here we just redefined it. We redefined it as player 1 again. So it just keeps checking player 1 over and over and over again. Okay. So how do we just move it outside of the while loop? Is that all we need to do? Yeah. Let's just move that outside the while loop. So we put it, whoops, tab. Okay. So if we assign it before the while loop, we go through, this will update it. We go through the while loop again. We already have the new check turn node. Okay. So that should work better. Okay. Yeah. Let's try that. Let's save it. Let's try it. And we've instantly crashed it. May need to step away from this as soon as I hear the garage door open so I can get some lunch. We didn't even get any output that time, so I have no idea, what was working and what wasn't. Maybe we should have done an array instead of a linked list. Maybe it would have saved us a lot of time. Hopefully, you guys still watching. Maybe you'll learn from my mistakes and you won't flub up like I did. Yeah, turn signals are not used. Yeah, I know I haven't used that yet. It's really weird because that should have at least gone through the first 2. Check turn node equals current turn node. Okay. So we're going to start with whoever's active. So if current turn node is null, add in current turn node equals new turn node. Okay. Just get rid of that. So this should break. So this is finding this. So this should find the spot. But we're not even getting to that because it's breaking before then. Where are we? Where are we? So we knew last time, before we moved that out of establishing that, it was breaking on pass 2. So pass 1 is working. If current turn node is null, we set player 1 as the, you know what, let's also just let's just do this. We'll make that player 1. Okay. Okay, so player 1, this works for player 1. We come back in here, we send in player 2. Player 2, we come in, we check player 2's initiative against player 1's initiative. Okay? Player 2's initiative is higher. So then we set all this up. Okay? We do assign all this fun stuff, yada yada yada. And then we turn the current check node to player 2 because current player 1's next actor has been set, right? Because next actor check turn node. Oh wait, did we never assign? Okay. So remember here in the beginning, we set the next actor self-referential. Okay. So we come in, we add number 2, and then we say the previous node Okay, yeah, so we're never updating the next actor for player 1. So this is always going to be player 1 because player 1's next actor is always player 1. So do we just add in a brute force check to say, hey, if their next actor is still the same? What do we I feel like how do I deal with that? How do I make it so the next actor of player 1 is no longer player 1? Because we don't want it to be null, because we want the loops to work both ways. So then we can move back and forward in the initiative order. So here we're setting the next actor. Previous node, next actor. So this is where it should be setting. So player 1's previous actor is going to be player 1. So player 1's next actor should be this one. But this is creating a reference. This is creating a local reference, not act. Well, that was weird. I've never actually seen that happen before. OBS Studio just disconnected. So that's weird. Welcome back. Let's make sure. Hold on. Let me make sure I have audio. Okay, I do. Okay, so let's resolve this, and then I'm going to need to take a break. So this previous node dot next actor we're only working with the local. We're not working with the actual node. Whoa, how do I do that? How do I actually update that previous node? What am I forgetting? I'm forgetting something here. Previous mode is check turn mode previous actor. Okay. Previous node, check node, previous actor. Previous node dot next equals the new node. And then the new node, previous, equals the previous node. Okay. What am I forgetting? I'm forgetting something. What am I forgetting? If check node equals current node equals new node. So in here, if check turn node equals the current node, current turn node equals new node? No, not new node. New, what did I call it? New turn node? If I do it that way, does that... Well, that's going to change my current turn. I don't want to do that. I don't want to do it that way. Because what I want to do is I want to... Oh, linked list. You're so much fun. So what did I do down here? So I got this is being updated. The new turn node, current turn node. We're setting that there. So I'm 90% certain this is the problem right here, because this is creating a local copy. And then this, what if I just change this to this? Check turn node next actor. Would that work? Let's find out. And I forgot to open the output window first. Oh, you know, this is one of those times where it might be most beneficial to step away, get some lunch, reconfigure yourself, and come back and figure out what's going on. So I think that may very well be what I'm going to do here. So let's I'm going to just try one more thing. I just want to see if we can get some output here because I had the output window closed. So let's just see. I know it's going to crash again, but at least we can. There we go. Now we have the output window. Let's see if we can get any output in the window. We do have output 5, 10, 15, 20. So it's going through all of them, but it's not breaking out of the. Okay. So I think. Yep. So we're actually going through all of them, but what we're not breaking out of that while loop. Okay. Stop and quit. Cancel. To this. Oh, it actually stopped. Yay. Okay. Okay, so let's see. We're not breaking out of this while loop. So while checking. Well, we'll just put that in there too. Okay, so we go through here. Next actor. If our check node equals the current turn node, checking equals false, break out. Okay, so that should be. Let's just do this stupid thing that we can do. Let's do a var loop. Loop plus equals 1. And then right here, just before this, let's print our loop. Okay. So you can see, like, roughly, are we getting through here? And if this is where we're failing to. 1, 2, 1, 2, 1, 2. Okay. Okay. Well, we're not really locked up. We just are partially locked up. Now we're fully locked up. Okay. It's only going through twice, Okay, so I think what I did was probably incorrect in my assumptions. So let's see. Okay, one more thing and then break for lunch. One more thing. Okay, close. Okay, it's going to crash, but I want to change back my previous node, next node thing. Right here, let's put that back to previous node. Okay, let's look at our output window and let's see what happens this way. And if my theory is right, this is going to get flooded. Yep. Okay. Yep. Perfect. Okay, so that's what I was thinking was happening. Okay. Yeah, so let's see here. Let's jump over to OBS. Actually, let's jump over to my timing. We're going to stop here. Okay. Let's go to Kanban. Movement system. Whoops. I didn't mean to do that. Movement system. Where'd it go? Oh, here it is. Movement system. Details. We got the heroes movement system. That's all done. We're working on the action turn system. So, yeah, I guess we don't get to check anything off today, unfortunately. But let's take a look here. Let's look at our chart. We have now spent 13 hours on Dungeon Fodder tiles. And this is where we are with 13 hours. Okay. So, oops, wrong button. Wrong button. Okay. So let's go. Where is my, oops, OBS? Sony. Wow. I need to clean this up a little bit here. And that's not working right now. So let's just go back to talking head. There we go. Perfect. That's fine. So, we've made a lot of progress today. I didn't quite get to where I wanted to be because I wanted to have that full turn thing in. I might do another stream later this evening because the baseball game this evening got canceled. So I guess I don't have to run out and deal with that. So maybe later this evening I'll do another one. But for right now, I think that's going to wrap us up. And if you have a chance, jump over to the Michael Games. He's about to do a live stream here very shortly. So have a good one, and I'll catch you later.